Hello, good morning to everybody. My name is Sheikh Nagud Mirawari. I am the lecturer in mathematics. Okay. Now we will discuss about the mathematical induction. Before going to mathematical induction, some basic concepts are there. So one of the basic concept is a statement. What is that? Statement. Statement. Simply, what is the meaning of the statement? A statement is simply a sentence. What is that? Sentence. But whether it is true or false, we have to decide whether it is true or false. Then it is said to be the statement. Okay. Simply, for example, the sun rises in the east. The sun rises in the east. Consider this sentence. The sun rises in the east. Okay. Is it true or false? Is it true or false? True. So, this statement is true. Next one more statement. The sun rises in the west. So, what is the statement? The sun rises in the west. The statement is false statement. Observe that always the sun rises in the east, but not in the west. But here in the second sentence, the sun rises in the west. So, this is the false sentence. So, in both of these sentences, we can decide it here. True. Second one is false. So, that's why these both are said to be the statements. That means they are the example for the statement. One more example. If x is equal to 2, then x plus 5 is equal to 2. Consider this sentence. Here, given that if you take an x is equal to 2, then x plus 5 is equal to 2. So, now we are going to check whether it is true or false. If x is equal to 2, then put x value in this equation. 2 plus 5 is equal to 2. That is 7 is equal to 2. So, this is the false. So, here also you can decide whether it is true or false. So, you have decided here what is that? False. So, that means this is also a statement. Example for the statement. One more sentence. X plus 5 is equal to 0. This is a sentence. Okay. Is it true or false? Decide here. We can't decide. Is it is true or false? Okay. For example, if we put x is equal to 2, then 2 plus 5 is equal to here 0. That means 7 is equal to 0. Here we get false. Suppose if x is equal to minus 5 you can take n, then minus 5 plus 5 is equal to 0. That means 0 is equal to 0. Here true. That is, this sentence sometimes false, sometimes true. That is, it is this sentence having both false and true. Hence, we can't say this is a statement. This is not a statement. Okay, this is the example for the statements. Okay, now we can write clearly what is the statement definition. Okay. Okay. Statement. A statement is said to be a sentence is said to be a statement if it is either true or false. If it is either true or false. True or false, but not both. This is the important, but not both. Okay. Every statement having the true values. The true values means here important. A sentence is true, then that is called true statement. Its truth value is T. A sentence is false, then that is called false statement. False statement, its truth value. Truth value is F. Okay, that is. Examples. The sun rises in the east. So this is the statement. The truth value is T. Second one. The sun rises in the west. The truth value is false. Both are the statements. Next one. If x is equal to 2, then x plus 5 is equal to 0. This is also a statement, but its truth value is false. So, they are the example for the statement. Observe that x plus 10 is equal to 2. So, is not a statement. Because of, if you take an x is equal to minus 8, then the statement is 2. Okay. Otherwise, if other than x is equal to minus 8, the statement is always false. That means sometimes it is true, sometimes it is false. That means this is both of the conditions satisfied. That means true statement and false statement. So this is not a statement. Okay. The statement containing only one true value, not both values. Okay. That is the concept here. Okay. They are about the statements. Okay. Now we will discuss about the progressions. Next step. What is that? Progression. Okay. Now the major concept is progressions. The progressions are two types. One is arithmetic progression, second one geometric progression. And one more progression is there, that is harmonic progression. First, the most important things are arithmetic progression and geometric progression. So, we are going to discuss about the first of all arithmetic progression. What is that? Arithmetic progression. Simply this can be written as AP, arithmetic progression. So, consider one example 2, 5, 8, 11 and so on. This is the one progression. Second one is 10, 8, 6, 4 and so on. Observe in this sequence, first one. In first one, the first term is 2. Second term is 5. Next term is 8. Next term is 11. Observe that the first term is added by 3. You will get the 5. So, if you added 3 here, you will get 5. After that, you can add the 5 to 3, you will get 8. Again add 3, you will get 11. That means here the very next term will be obtained by adding 3 and its preceding term. So here the common difference. So that 3 is called the common difference. How do you get this 3? 5 minus 2. Next 8 minus 5. Next 11 minus 8. In the same way here observe that 8 minus 10, that is minus 2. Here also 6 minus 8 minus 2. Here 5 minus 6 minus 2. So here the common difference is minus 2. So such type of progressions are example for the arithmetic progression. That means in arithmetic progression, the every term having a common difference, and a term after a term is obtained by adding its preceding term by a constant value. So that constant value is called the common difference. In the first example, the common difference is 3. The second example, the common difference is minus 2. Okay. Okay. Now arithmetic progression. So the progression is of the form. The progression is A plus D, A plus 2D, A plus 3D, and continuing this is called an arithmetic progression. Simply it is denoted by AP. So if you consider this is the arithmetic progression, where the first term, what is that? A. That is called the first term, where A is first term. First term will be denoted by T. So if it is the first term, you can write T1. So the first term T1 means we can always say that A. Next one, the common difference D. D is called the common difference. Common difference. So how do you get this common difference? Second term minus first term, or third term minus second term. So or nth term minus its before term, that is n minus 1th term. This is the arithmetic progression basic letters. What are the arithmetic progression basic letters? First term and common difference. Okay. Now the general term of the arithmetic progression. General term of arithmetic progression, that is denoted by, that is called, the general term means, or this can also write as nth term. Nth term. So this is denoted by Tn. The formula is A plus n minus 1 into D. Okay, this is the nth term formula. That is general term formula. Here observe that in this one, this is term 1, this is term 2. Here the suffix value is 2. Now the D coefficient should be 1. Next this is third term. Here D coefficient 2. T4, D coefficient 3. And we get here 10th term. How much you will get? A plus, here 10 is there. Now you will get 10 minus 1. That is 9D. This is the 10th term. Like that. Okay. Now the formula. One more formula. The sum of first n terms in the arithmetic progression. The sum of n terms in AP. Sum means the first letter is S. This is denoted by S. N term means Sn. So formula is n by 2 into 2a plus n minus 1 into D. This is the sum of first n terms in the arithmetic progression. So they are the major formulas about the arithmetic progression. Okay. Now we had discussed about the arithmetic progression. In arithmetic progression, the first term is A. One more thing is the common difference D. That will get a difference of two successive terms. Okay. There will be common difference. Now we are discussing about the geometric progression. In geometric progression, in the same process of the arithmetic progression, here the new thing is the common ratio. So the geometric progression is of the form, the progression AR. In arithmetic progression, some quantity will be added the next term. Here in geometric progression, the constant quantity will be multiplied by its next term. Okay, AR. Now AR square, AR cube, and so on like that. So this is where A is the first term, term 1. That is first term. The new letter will be there here. What is that? R. This is called, the R stands for ratio. So here this is called common ratio. Common ratio. The formula is T2 by T1, T3 by T2, and so on, or Tn by Tn minus 1. Now the general term, or is also called nth term of GP is Tn is equal to A into R to the power of n minus 1. This is the general term of the geometric progression. Next one, the sum of n terms. The sum of n terms in GP is Sn is equal to A into R to the power of n minus 1 by R minus 1. So this is the sum of n terms in geometric progression. Next one, here one more formula is there, that is the sum of infinite terms. Infinite terms. The sum of infinite terms is denoted by S infinite. The formula will be A by 1 minus R. Here the condition is modulus of R is less than 1. That means the R value is always less than 1. Then we can use the sum of infinite terms in the arithmetic progression. If R value greater than 1, there doesn't exist the sum of the infinite series of the geometric progression. So if R lies between, where that means modulus of R is less than 1 means minus 1 less than R less than 1. Okay. In such type of case, we can only find the sum of infinite terms in the geometric progression. Otherwise, we can't find the sum of infinite terms in the geometric progression. Okay. These are the main things of the progressions. What is that? Arithmetic progression and geometric progression. Okay. In the same way, we will discuss about the some summations. So first one, the sum of first n natural numbers. So sum of first n natural numbers means natural numbers are started with 1, next 2, 3, 4, up to and so on. How many natural numbers we have considered? N. So we are going to do the sum. Sum of the first n natural numbers means like that. Is equal to, the formula is n into n plus 1 by 2. This is the sum of first n natural numbers. Okay. Now this can also written as sum of n natural numbers, that is n into n plus 1 by 2. So this is next one. The sum of square of space of n natural numbers. N natural numbers, that means space of n natural numbers, that is 1 square, 2 square, 3 square, and so on, n square, is equal to n into n plus 1 into 2n plus 1 by 6. So this can be simply written as sum of space of n natural numbers, n into n plus 1 into 2n plus 1 by 6. Next one, the sum of the cubes of n natural numbers. This is denoted by sum of cubes of natural numbers, that is 1 cube plus 2 cube plus up to and so on, n cube. The formula is this one, n into n plus 1 by 2 whole square. That means this answer should be equal to the sum of the square of the sum of the first n natural numbers. Okay, so they are the major concept formulas of the mathematical induction. Okay, thank you.